So here we are. This is part 2 of our graphing rational functions frame. And to kind of summarize what we've done so far, first of all, we're just using this frame as a reference document that tells us all the things we need to know and need to think about when we graph rational functions. And really, it's about understanding the properties and the behaviors of the rational functions by translating between the equation and the graph. And that's what we did here. First, we're given this very simple rational function. We created a bunch of we chose a bunch of x values and figured out the corresponding values of the function for those values of x, and we used those points to plot and create this graph. So that's the first time we were ever expected to explore the graph of a function. We might make tables of values and plot them. And we learned that this particular graph gets closer and closer and closer to this line x equal to 0, both in the positive and negative side of the graph, but it never quite touches or crosses that line. And that line is a vertical asymptote. And we find the vertical asymptotes by considering those values of x that cause division by 0 in our rational function, and thus cause the function to be undefined. And then we did that when we explored these values here that are really close to that value of 0 that causes this function to be undefined. And so we say that f of x, this function, has a vertical asymptote at x equal to 0. So we also want to explore horizontal asymptotes, and that's really what we're doing over here. We're going to find horizontal asymptotes by considering end behavior. And maybe you can look at the graph already, since we have it here, and imagine what happens to our value of the value of the function, that is our y value, as x approaches infinity. As x gets bigger and bigger and bigger, 1 divided by x gets smaller and smaller and smaller, and it closes in on what appears to be 0. And I just want to test that out a little bit, and we're just going to make another table to think about it. Here's x, here's f of x, and we have a very simple function. So let's just start. We already plugged in a bunch of numbers over here, but I'm going to start with x equal to 10. And if I put 10 into this equation for x, I get 1 divided by 10, which is 0.1. And then I'm just going to add another 0 on my x value. Now I'm going to do x equal to 100, and I get 1/100th. If you're not sure, just plug it into a calculator. 1 divided by 100, that's 0.01. I can even go to 1,000, and I get 0.001. So you can see what's happening. X is approaching infinity in this column, and our value, the value of our function, is approaching 0. So let me fill that in. As x approaches infinity, this is how we write about end notation. As x, or end behavior, I should say, as x approaches infinity, f of x approaches 0. Of course, I also want to explore what happens when x goes to negative infinity. So I could do a negative 10, and I get negative 0.1. And if I go negative 100, I get negative 0.01. And if I put in negative 1,000, my function goes to negative 0.001. That's negative 1/1000. So basically, as my x value is going to negative infinity, the value of my function is approaching 0. And it's approaching 0 from the negative side, just like my graph is over here. I'm coming up from the negative side, and I'm getting a negative number that's closer and closer to 0, and eventually, if I was able to go all the way out to infinity, then I would get to 0. So let me finish my end behavior notation over here. As x goes to negative infinity, f of x also goes to 0. So f of x has a horizontal asymptote at y equal to 0. And let's look at the graph. This is the line y equals to 0. And so, again, we usually use dotted lines to represent our asymptotes. It's a little tricky because our asymptote is actually right on the axis. But I'm also going to label y equal to 0 right here on my graph. I'm going to just say that that's a horizontal asymptote. Okay. And so this is how we produce a graph of a rational function. Certainly, we can always plot points, but we should be able to sketch rational functions pretty quickly by first looking at the values that cause division by 0 and putting our vertical asymptotes on our graph. And then we look at the end behavior, and we can do that just by plugging some numbers in for x, or we can plug the numbers in our heads. Sometimes our functions are simple enough that we can just imagine what happens as x goes to infinity, what's going to happen to the function itself. If you need to plug some numbers into a calculator, that's fine too. And so from this information, we get our horizontal asymptote, and then we can just draw these curves that fit between the asymptotes in order to complete our graph. And we'll have some practice doing this on the next problem set. That is taking a rational equation and then constructing the graph based on the vertical and horizontal asymptotes that we found.